Question 22. Evaluate the definite integral from 1 to 2 for the expression 5x plus 1 dx. Here in this question I think it's very simple for you, but we have two types of integration or integrals, definite and indefinite. In indefinite integral we'll integrate using rules of integration, but we'll add plus c after integration. In definite integral like this, we will integrate the expression, but we will substitute by the 2 bounds of integration, this value and this value, to find a number. So we will integrate this expression. So whatever it's definite or indefinite integral, we have to integrate this expression. The expression 5x plus 1, as we can see here, it's 2 parts, between them plus. So we'll integrate each part separate. So it will be 5x to the power of 2 divided by 2. Add 1 to the power, divide by the new power, plus x. Basically it's 1x. As we said before, integration of the absolute term, just add the variable. So it will be 1x, but we'll not write 1. It's mentally written x from 1 to 2. Instead of writing plus c after integration, we'll put these two numbers and substitute by each one. In the first step, we will substitute the first number is, or the bigger number, which is 2. Put 2 in the place of x and calculate. And the second part, put the other number, which is 1. Put 1 in the place of x and calculate. Then we will subtract the two answers. The first one is 12. And the second one is 7 over 2. This value minus this value. So it will be 12 over 1 minus 7 over 2. Using calculator, it will be 17 over 2. Or you can write it as decimal, it will be 8.5. If you ask to write it as decimal, you can change, otherwise you can write it in any form. Question 23. Find the volume of solid generated by rotating through 360 degrees about the x-axis, the area bounded by y equal x to the power of 2 and y equal 3x. Here it's a volume of revolution. As we said before, that the rule of volume of revolution is definite integral from a to b, which are the bounds of integration, pi of y2 to the power of 2 minus y1 to the power of 2 dx. Don't forget it's power 2, y2 to the power of 2 and y1 to the power of 2. Here it's y1 and y2. We have one expression. If we have one function, it will be here only one function. If we have two functions like this question, you have to write it y2 power 2 minus y1 power 2. We have to put each value in its place and integrate, calculate to find the value as the previous question, which is definite integral. Here it's pi and it will be written outside the integration. y2 equal 3x to the power of 2 minus y1, which is x power 2 all to the power of 2 dx. Here the problem is, what are values of a and b, bounds of integration? Sometimes the bounds of integration are given in the question, so we write them direct. If one of them or both of them not given, we have to find by subtracting the two functions from each other. So y2 minus y1 equal 0. y2 equal 3x, y1 equal x to the power of 2 equal 0. By solving this equation, we'll find values of x which represent the bounds of integration. Here, as we can see, that there is a highest common factor, which is x. Here 3 minus x equal 0. So each part equal 0, either x equal 0 or 3 minus x equal 0. So this is the first value, and here x equal 3, it's the second value. So the bounds of integration are 0 and 3. 0 will be written down and 3 will be written up. Small number down and big number up. As we said, pi will be written outside the integration, and 0 to 3. We will simplify this expression. It will be 9x to the power of 2 minus x to the power of 4 dx. As the previous question, we'll integrate this expression and substitute. And don't forget pi outside. Integration of 9x to the power of 2 by adding 1 to the power and dividing by the new power. It will be 9x to the power of 3 divided by 3 minus x to the power of 5 divided by 5 from 0 to 3. Here mentally we can cancel substituting by the number 0 because it will give 0. So we'll substitute by only one value, which is 3. 9 multiply 3 to the power of 3 divided by 3 minus 3 to the power of 5 divided by 5. Using calculator, you will get the value of this question, which is 32.4, and don't forget it's multiplied by pi. Here there's an important point. It's the final answer, but we have to say an important point. Here the 2 bounds are 0 and 3. We said mentally we can cancel 0, but in case it's the smaller number. Because if we have two numbers, one negative and 0, 0 will be the bigger number. Here in this case we have to substitute by 0 because we'll get negative sign. Or the two numbers will be without 0. So we have to substitute by the two numbers to get the answer. So we have to pay attention in this question. Not in all questions we can cancel substituting by the part or by the number 0 in this expression. The first case we have to substitute by 0 if 0 is the bigger number. Second case, if there is an absolute term. If there is an absolute term we have to substitute by 0, because we cancel substituting by 0 mentally if substituting by 0 will give 0. But in the first case, if it's the bigger number, there will be negative 1. There will be negative sign, we can't cancel. In the other case, there is an absolute term, so the value of the expression will not be 0. So as we are solving this question, definite integral, we have to focus on this point. Question 24. He said show that definite integration from 0 to 1 for the expression e to the power 2x plus 3 e to the power of x plus 2 over e to the power of x plus 2 dx equal e. Here in this question there is an important idea. We'll use this idea whatever the form of the question. Here he said show that, he can ask also prove that, he can say evaluate, or he can take this expression only and they will say simplify or solve equation like this. In all of these forms we'll use the same idea. What is this idea? Is simplifying the expression. We said simplifying expression is used in so many questions to simplify calculations or to use sample methods, especially in this integration, which is in form of dividing. Instead of using quotient rule, we can use, or we can simplify the expression to use another method which is more simple than quotient rule. Here we will simplify by factorization, and you have to pay attention about this idea. We'll simplify using factorization, factorizing numerator, denominator, or both, and cancel like terms or like parts, then we'll take or we'll get an expression which is more simple than the original one. Here, integration from 0 to 1, we will factorize numerator. It will be e to the power of x, e to the power of x. Here this sign is positive, so the two signs will be similar, same as the middle sign. It will be plus plus. We have to find two numbers, their product equal 2 and their summation equal 3. It's 1 and 2, divided by e to the power of x plus 2 dx. Here we can see that we have two equal parts, so we can cancel the two equal parts, so we get integration in this form from 0 to 1 for the expression e to the power of x plus 1. And here you have to pay attention, plus 1 is not in the power. Plus 1 is not in the power. E to the power of x plus 1 not equal or not the same or not equivalent e to the power of x plus 1 dx. Here it's very simple to integrate this expression. We'll integrate the first part, integrate the second part, and substitute by these values. E to the power of x, its integration, e to the power of x, plus integration of 1, as we said before, is x, from 0 to 1. Here in this case, we said we have two numbers, or one of the 2 pounds of integration equals 0. Can we cancel here the part of substitution by 0? The answer is no. And we'll see why now. We'll substitute by the first number, e to the power of 1 plus 1 equal. Here e to the power of 0 plus 0. The value of this part in which we substituted by 0 not equal 0, it's equal to 1. So we can't cancel this part. E to the power of 1 plus 1 equal e plus 1. If we subtract this part minus this part, so it will be e plus 1 minus 1 equal e equal right hand side. If he said evaluate, it will be the same solution, no difference. If he said prove that, it will be the same solution, no difference. But the difference between question, if he said show that or prove that, and evaluate, is in show that and prove that, we know the final answer before solving. So we can check our answer. If we get the same answer, we can say that we are correct. Different or not the same, so we can say that there is a mistake and we have to revise. But if he said evaluate, you will get an answer. Most of times you can't know that it's correct or wrong.